So I'm going to start out with a kind of a sad picture to start out with. This is the 100th anniversary of the worst pandemic we've ever had. The 1918 influenza pandemic, which spread throughout the world, and in less than 2 years, this is how many died. This is actually something that can still happen again. I read in the Wall Street Journal last week that they expect another pandemic like this, but it's going to kill more because of our global travel and the urbanization that we have. So it can get worse. And just think about the current flu that we have right now. The current vaccine is only 30% effective, and we can't do a damn thing about it. Okay? There's no flu that we can flu vaccine that we can respond with. We just have to endure it. So a lot of people are going to die because of this. That's because we can't respond. We don't have the ability to do it. What we need to do is find a way to make quick response, rapid response, and cheap response to get vaccines out there. Let's look at a few other diseases that exist out there. Rabies currently kills 50,000 people every year. If we had an effective, low-cost vaccine, we could stop that disease. Let's look at a cancer. The human papillomavirus causes cervical cancer. It's currently the second leading cause of cancer death of women in the world. It's caused by a virus that if we have a vaccine that's low cost and effective and can be rapidly dispersed, we could actually stop this. In the developing countries, the cancer death from this virus, cervical cancer, is basically the leading cause of death in developing countries. Let's look at some other ones that are slowly approaching from the south. Dengue. Dengue currently affects 50 to 100 million people every year. Of those, 500,000 get hemorrhagic fever. Of those, 22,000 people die. This every year. If we had a good, effective, and low-cost vaccine, we could stop it. Then take a look at Zika. So Zika, we know that mothers of the Zika who have been infected with the Zika virus may have a lifelong problem and their child will be developmentally challenged. Okay? If we had a low-cost and available vaccine for Zika, we could stop that. So your question is, how? How can we have low-cost, effective, and rapidly dispersed vaccines? I'm going to tell you how. Okay? Plants. Not that plant. This plant. Okay? So this little guy here, take a look at this little guy, at this size, can make enough human vaccine for 5 people. And it can make it quickly. I'm going to show you how in 1 week this little plant can be made to make a vaccine for 5 people right away. So because of this, I'm going to have to talk a little bit about technology. Sorry. So let's talk about plants and plants viruses. Plants have viruses just like we do. The one thing that's kind of neat about them is even though they look like ours, they have no ability to infect us at all. You eat them every day. I was a certified organic farmer for a long time. I ate a lot of plant viruses. But here's what's interesting. If you were to take a plant virus and inject it into me, my immune system is going to see it and say, that's a virus, and it's going to make antibodies against it, and it's going to get the best immunity against that damn little thing that can't hurt you. Okay? So that's a neat thing to know. So what I'm saying is, let's take that innocent plant virus that can't cause disease, let's put a costume on it to make it look like a human virus, to basically decorate the outside so it is an actor playing the role of the actual disease agent. Then if I were to inject that in me, and now it's in a costume, it's just an actor in a costume, now if I inject that into me, it's going to respond, and it's going to, boom, my immune system's going to see it, see that the actor, and build up good antibodies. Then when the real one comes, looking like that, my immune system knows what to do. It's had the practice. Pretty cool, huh? Okay, so let's go a little bit deeper on this. So how do you make this decoration happen? How do you get this costume on the outside of it? I'm showing you two subunits of a plant virus. And of these, we now have the genetic capabilities to add some sequences. So on the outside surface of a plant virus, we can add new protein information. And what we're going to add is snippets of information that's found on the real pathogen. Just tiny little pieces to do that. So basically, here's what we're doing. We've now added the new sequences on it. So when this thing assembles, we have both on your left-hand side, you're going to see the virus that does not have the costume. On the right-hand side, you see the costume. My immune system's going to see this costume. It's going to make antibodies. It's going to be ready for anything that comes looking like that at all. So when the real one comes by, my immune system is ready to respond. And all I've done is taken a little plant virus and put a costume on it and made it become an actor. So that's how it's going to work, okay? So what I see is a way to globally spread this ability to make them around the world. Because I want rapid response, I want low-cost response, and I want it to happen quickly. So the plants can be grown around the world, and the reason why it can be done globally is that the idea of being able to patent and the technology the technology for making that costume currently is off patent. So anyone in the world can put costumes and develop costumes to take these viruses and turn them into a costumed vaccine. Okay? Pretty neat. Okay, so here's the steps I see for a disease outbreak. Number one, we have an outbreak, you have a disease you just want to take control of, you have a pandemic, you have an epidemic, you have something like that happening. What you need to do is go find the pathogen, find a little snippet of information on its outside surface, and that's going to be the piece of costume you're going to put on the plant virus. So you're going to decorate the outside of the plant virus to look like it. But now I've just made some in the lab, not nearly enough. I want to make more than 5 doses. I want to make millions of doses. I want to be able to respond. Just this one little five doses is not enough, okay? But if I get 1 million of those plants, that's going to do a lot better. But I'll show you what we can do even more than that. So now we have plants, we have the costumed virus. What we're going to now want to do is actually get the virus in millions of plants. So I'm going to show you a facility that exists and can be made all over the world. But basically, this facility has 4 million plants in it, just like these, 4 million of them. They can actually take a full 1 million per week and basically introduce this costumed virus, which is really going to be a vaccine, and in 1 week, it's going to get it. So what we have to do is get it in. So you put the virus vector and you put it in a solution, you dip these plants down inside, you pull a vacuum, all the air comes out. When you release the vacuum, this vector comes in, and now we have the costume virus being in every single cell of all those plants. If you do 1 million a week, that's 5 million doses. If you take a month, we got 20 million doses. If you have 10 facilities around the world, that's 200 million doses. If you have 100, that's 2 billion. We're going to stop anything very quickly by this technology. So you can say, okay, Larry, that sounds fine. Maybe you can grow all these plants. Maybe you can dunk them all. Maybe you can make the costume. Maybe this can work. But how can you do it? Okay. So here's our vaccine. I'm going to show you what we actually did do. Okay. I've been working with the people in Botswana for a while now, and some of who have actually come here and are working here with me. And basically, what we've done is we've found a disease for which there is not a very good, inexpensive, available vaccine. And the disease is lumpy skin disease. Now, this is a disease of cattle, not humans, but the same thing. They have the same kind of immune system that we have. This disease is devastating to all the smallholder farmers around the world. It is bad, okay? So what we did is we came there and we took this plant virus and we took a snippet of information from that lumpy skin virus, and we put it on the outside of ours. So we costumed our plant virus that, again, can't cause disease, and we made it look like the lumpy skin disease virus. And then what we had to do, we inoculated the guys, and some of them, not all of them, and we let the vaccine affect them, let their immune system respond, and then what we did was kind of the nasty side of things. We actually challenged them with the actual virus. So now imagine they have now seen this imposter, this costumed plant virus that looks like it, has snippets of information from it. Now we're actually going to challenge it with the real stuff. Well, to simplify the graph, the cattle that got the vaccine did not get the disease. And those that got the disease got it because they did not get the vaccine. So this costumed plant virus actually can be a vaccine. And it is low, it's cheap to grow plants. Okay, everyone can do it. I've done it, even though my tomatoes are probably more expensive, the ones I grow, than the ones I can buy in the market. Everyone can grow, everyone can make plants. Plants are cheap to grow. All they need is a little bit of soil, a little bit of sun, and they're there to make it for us. So we can actually do this fairly inexpensively, and we're hoping to continue this on. And I see a world in which we're going to have a rapid response to a disease outbreak. We're going to be able to control diseases that we're not doing a very good job of now. And if that next pandemic comes, that's going to have the flu that can kill 50,000, 100,000, 200,000 people, we're going to stop it before it gets a chance. Thank you.